Okay, welcome back. So this is a question under empirical formula. It said determine the empirical formula of an oxide of nitrogen containing 70% of oxygen. If the relative molecular mass of the oxide is 92, calculate its molecular formula. See, anything about chemistry calculation or physics calculation, first you should understand what they are asking you to calculate for. First of all, understand the question before you start your calculation. Okay, let's read it again. They said determine the empirical formula of an oxide of nitrogen containing 70% of oxygen. So meaning oxygen is 70%. If the relative molecular mass of the oxide is 92, calculate its molecular formula. We are asked to calculate for two things. One, the empirical formula, and two, the molecular formula. So let's first calculate for the empirical formula. Here we are given two elements, nitrogen and oxygen, right? Are given nitrogen and oxygen here. Okay, so here the percentage containing 70% of oxygen, right? So oxygen is what? 70%. But nitrogen is not given. So what are we going to do? What is the percentage of nitrogen now? Okay, let's understand something here. Since the question said oxygen is what? 70%. And percent means what? The total is what? 100. Meaning what is remaining to complete 100 is 30, isn't it? So 70 plus 30 is what? 100. So the percentage of nitrogen here is what? 30%. Are you getting it now? So we have nitrogen is equal to 30 and oxygen is what? 70. So let's continue. You know, any calculation under empirical formula, after they are given percentage, what you need to do is to divide them by their atomic masses. So you know the atomic mass of nitrogen is what? Is 14. So divide by 14. While the atomic mass of oxygen is what? Is 16. So 30 divided by 14 give you 2.1 equal to 70 divided by 16 to give you 4.3. So you have 2.1 and 4.3, right? So the next thing you need to do is to divide them by the smallest number. So between 2.1 and 4.3, which one is the smallest? We know that 2.1 is the smallest number, right? So divide by 2.1 divided by 2.1. Are you getting it now? So 2.1 divided by 2.1 will give us what? 1. Same thing as 1. While 4.3 divided by 2.1 will give us 2.1. Are you getting it? So we see that nitrogen is what? 1, while oxygen is 2.1. So let's write down the empirical formula they are asking for. You know the two elements are what? Nitrogen and oxygen, isn't it? So what is the name of this compound now? To what? Nitrogen 2 oxide. So let's write the empirical formula. So these are the two elements. So nitrogen is 1. No need of writing it here. While oxygen is what? 2.1. So we write 2. I get it. So we have one atom of nitrogen and two atoms of oxygen. So this is what? Nitrogen 4 oxide. Are you getting it now? So the second one is if the relative molecular mass of the oxide is 92, calculate its molecular formula. Let's calculate for the molecular formula. So this is the empirical formula, right? Let's put it in bracket. Multiply by x equal to, said the oxide is what? 92. Are you getting it now? It is 92. So let's calculate for the relative molecular mass of nitrogen 4 oxide. No, the atomic mass of nitrogen is 14 plus atomic mass of oxygen is 16 multiply by 2, x equal to 92. So we have 14 plus 16 times 2 to give us 32, x equal to 92. So 14 plus 32 give us 46, x equal to 92. So make x the right of the formula. So x equal to 92 divided by 46 equal to 2. So 92 divided by 46 is 2. They said we should what? Calculate for the molecular formula. So let's write down the molecular formula they are asking of. Note that this one is for the empirical formula. This nitrogen 4 oxide is the empirical formula. So let's write down the molecular formula. Okay, this is how to write the molecular formula. We have one here, meaning one atom of nitrogen, and here is two, so meaning two atoms of what? Oxygen. Why here we calculate for x, which is what? 2. So let's use this 2 to multiply everything here. So 2 times 1 will give us 2. Why oxygen? 2 times 2 will give us what? 4. So this is the molecular formula. So meaning we have 2 atoms of nitrogen now and 4 atoms of oxygen. So this is how to calculate for both empirical formula and the molecular formula. In case you don't understand, you can rewatch the video. Okay. If you are not subscribed to this YouTube channel, subscribe. If you are watching on Facebook, follow this page for more videos. Please like, comment, and share. You are encouraging me to post more videos. Okay.